Hello, very good afternoon. It's once again it's an opportunity to introduce you all to experts and leaders in 3D technology and services, and also 3D technology respondents who've been really working towards in terms of offering unique solutions in this space. So 3D Graphy News has been an active respondent in terms of being a catalyst, in terms of being an information source for 3D technology companies as well as for the end users. So it becomes a platform to engage and also actively see that how these technologies can benefit for either of these parties, and also for researchers and scientists who are working on various new materials and solutions. So 3D Graphy News will include information on 3D technology, wherein 3D printing, 3D visualization, 3D imaging, 3D simulation, software, and also materials. So material science is a very important aspect of this. And today we have an opportunity to introduce you to Dr. Karthik Balaji, who is the founder of Zoriox. Yeah, Zoriox is a company, and they've been actually offering solutions in dental, medical, orthopedics, prosthetics, and even into medical devices. And 3D technology has been primarily a technology where they have been able to utilize it well to the extent of what was actually required. Before me sharing more details, I would rather have Doctor to share his inputs. So quickly, Doctor, thank you so much for your time. And it was good to know that the technology is gaining a lot of traction in dental and also medical. And you've been working in this space for a long time, I know. But for the audience sake, if you can just share your experience and where it all started, please. Thank you.
Yeah, actually, it all started from my thesis, like where I had to do my thesis on fibula graft. So from there, we were like planning to do something like let's make this harvesting of fibula easy and shaping all those things. We wanted it to be made easy, and we started to adapt to a method called stereolithography or rapid prototyping on those times. So we started with that, and slowly we were working on that. Then we thought of why not using titanium for to fill all the deficiencies in the mandible and maxilla, where like we are using mini plates, right? Why can't we use the same concept here? And that's how it all started for us. And we were planning to we planned to do our mandible reconstruction and all in 2014-15. It happened, and we had some difficulties with that. We went through all those things. We had to face all the difficulties, failures, everything. And then a lot of advancements happened. Better printers came into the field. Better designing tools were there. So we started adapting ourselves to all those tools. Before it was monopoly, then there were some 4-5 softwares, and we also work on different CAD softwares with which we can do better implants. We were able to do we were able to see what the shape is, the size, and the strength of the implants by simulations. We were able to do all those things with modern softwares. So this led us in making of the implant, and then even we being surgeons, that was an easy part for us, like keeping the implants inside. So like we had a good team of surgeons, experts actually, who wanted to work with us, and the team is working with me for last 3 years. And right now we started with 5 cases in first year, second year we had 20 cases, and end of third year we are having almost 350 implants. And we have reviewed almost 250 cases in that. All are good, and we used to do like reviews once every 6 months with all the doctors with whom we are work. They bring all their cases. We review, see what are the advantages we give the doctors, what are all the disadvantages, how we can rectify all those things. So that's the way pattern we have worked, and now we have reached a good number. Let's see where it goes. This titanium implant is good, but now also like we are working on a method where we can actually replace normal bone with a bone, not with an implant. Whatever it is, it can be the golden standard of biocompatibility, but we are seeing into that, or else how this can be incorporated with making bone growth feasible. We are working on all those lines now. So that's what our journey is.
Okay, so that's a very futuristic way of looking at creating new opportunities also with innovation, Doctor. I appreciate that efforts made. But do you think beyond titanium, are you comfortable even using PEEK? Because PEEK also happens to be a very good material for reconstruction, is what I've been told, and for cranial implants to an extent. And and also your recent efforts been made, and also not the recent ones, because it's been last 2 years we've been all suffering from COVID and the cases of mycomycosis, and you have been able to achieve some good effort there. Can you please explain? One is on the material part, and then mycomycosis in terms of your efforts made on that subject, Doctor.
See, coming to the material, yeah, PEEK is a good material, but we have doubts with when it comes to weight bearing areas or functional areas. Yeah, as you said, cranial vault, the function is not going to be there. It's just go to stay there, or a orbital rim or something which is going to be inside the tissues. We don't have to worry about the weight bearing or functional. But speaking about maxilla and mandible, these two things, they are going to take the workload, the occlusal pressure. So we don't stick to peak in those areas. That's when we either it should be a bone or a titanium. Okay, olden days stainless steel was there, but now we are not using it. It has other complications. Titanium is very friendly according to us, and we were able to do a lot of designs, and the strength is also good even if it is used in a very thin structure. So we didn't have any problem with titanium till now. We are happy, so we are using titanium. So what is the
No,
other
no.
thing you are
So
asking?
I was relating peak with the orbital floor, if that is an option, because there
Yeah.
you don't have much.
Yeah, orbital flow definitely peak can be used. Orbital flow definitely peak can be used. Okay, but the cost factor is another thing which we have to see when it comes to peak.
Yeah, yeah.
Okay, so peak is yeah, it is lightweight, but I don't think even titanium is heavy. It is also lightweight. It's not very
Right.
heavy. Okay, now so there is not a vast difference in the weight. So I don't think peak can replace titanium. Titanium will stay the golden standard. We all thought peak is going to become the golden standard actually 2 years back, but I don't see it going that way. But the bone is coming, like the hydroxyapatite and other things, where infusion of bone or a creeping of the bone structures into the titanium implants, all those facilitations can be done nowadays.
Right.
So more of osseointegration is planned by a lot of people, and doctors working with us are very much interested in doing cases like that. They are not just like Karthik, just let's go for reconstruction. They are like some of the doctors even speak about angiogenesis through our implant, through which the bone can form. All those things are happening. So the thing is, in India, we don't have the right place to do all those research work, and the facilities are not there. But I'm sure it will all come up. Like a few states, like they are working on it. Even center is pushing it a little. So let's see how far it goes. How, like in research, how much our country is going to support the
No, no.
youngsters.
So, Doctor, when you
So
said about research, see, we have a consortium. 3D Graphic Consortium has various researchers from various institutes, like the Indian Institute of Science. We have Dr. Bikramjit Basu, who is also
hmm,
one of our key respondents. So he is somebody who's been doing a lot of research on material science with hydroxyapatite and various different materials also. What we also understood is that hydroxyapatite mostly for load bearing in orthopedics, we are also looking at to an extent of seeing how these materials can be of benefit. So oyster induction is also one of the key aspects for all these aspects. So we have researchers, doctor. So in fact, we will also want to align with you in terms of connecting with you, and because that's the intention of the consortium. It is also to see that doctors and surgeons get that kind of a pathway to connect with researchers and scientists who are also working in closed doors. Though I mean that's the way system works. But now with this new developments in new materials, there is a lot of work even happening with IIT Bombay. Dr. Jayesh Balare, he is also one of the key respondents. He's been doing a lot of resorbable materials as an option. Then we have Dr. Shantanu Dhara from IIT Kharagpur, IIT Guwahati also. Yeah, IIT, he's from IIT Guwahati. So there are respondents who are doing that. But where I'm seeing is, as you rightly mentioned, titanium being one of the best solution today to be a choice for a mandible reconstruction and head and neck in terms of most of the option, right, doctor? And now that you mentioned that, design for all these anatomy is also very, very important. So how do you manage to do that? Do you have an expert team to do that in-house, understanding this design when it comes to the anatomy?
Yeah, we have a team of designers. Like our designing team has mech, biomed, dentist, anatomist. So it's a nice team of youngsters. So they do a good job for me. The only thing what I did was just tell them what the anatomy was during my initial stages, and we have been working together for almost 2.5 years now, the whole team. So there is no confusion in doing the designs. That is not there, and everybody is well informed about the other technology. Like the doctors know what the engineering side is, and the engineers know what the anatomical side is, even the physiology. So we have a general knowledge of the whole thing, the whole the the mechanical and physiological properties of all the anatomy of face, especially face. We will work more with face. So we have a very strong team there. So that has helped us come this much actually, or else it would have been very difficult having one engineer or having one surgeon and sitting here and doing everything. And we have a team. So the team is, and we also have a graphic engineer and a coder. So they are also working with us to accomplish a lot of stuff. So this is what our team is. Now we are planning to expand it more, with more of production engineers, more than mechanical and biomed. We want production side to come in, and we are searching for. So if someone needs, they can apply us. So who has done a sandwich for production and mechanical, all those sort of people can come in, which will be very useful for them, because this is a very new industry. See, all people are going and falling into IT, rather than they can come venture in these fields and they can do something new. And we are always here to encourage youngsters. So a lot of studies has been taken by youngsters here. Both doctors and engineers, they are doing a lot of studies with us. So we are supporting them. Let's see what the results are, and then they will start publishing it.
Doctor, one more thing is, as you rightly mentioned about youngsters, so I think biomedical engineers and engineers for that matter, even mechanical engineers who have also interest in anatomical, body function and seeing, how these construct can be rightly done, and want to get into design can also be trained on the subject. So what we see is, how do you see an opportunity to address institutions for students to come out with problem statements, or even doctors for that matter, because even they can work in confluence. So, students, professionals, all working in confluence together, understanding the potential of 3D technology in the medical, in the medical area of specialization. Uh, uh, do you think that a company like yours could probably contribute, or you're already doing it in a way? So, largely, are you also in terms of working in with institutes also, doctor?
Yeah, we are working with institutes. We are working with doctors. I can't say institutes. We are working with lot of doctors, in the sense we are teaching them designing also. Okay, let them come and do the designing here. We have lot of doctors who come and work in nights here, night 1 o'clock, 2 o'clock. They come and work here. So they are also form, they come into my team actually. Okay, we have the paperworks done, all those things, and they come into my team. They work, because they can't come during the evenings. They either come in the afternoons or they do come in the nights and use our softwares, because this office is open 24 hours a day. So they can come anytime, they can work on it, on the designs, and then we have a good designing panel which that approves the design. Okay, it's just not the doctor's approval, it's the designing approval, because the doctor will worry about the easiness of keeping the implant inside, and also the area where we are going to fix it. The engineers worry about the strength and the fatigue of the implants, how it's going to be, all those stuff. So it's a good teamwork, that we are able to give good implants. Coming Speaking about institute, we have signed a MOU with few institutes where we are working with regularly on educating their students on these technologies, how to do it, because they are the future. So we are educating them, and we don't put in like these are the things which you have to do. It's like we are always open to their ideas, and the youngsters come with lot of new ideas. Like in fact, initially it will look like some crappy idea actually, but that will work out very nicely in the end. So all those things, like I learned it from the youngsters. Like just do whatever you feel, and one day you will have the results. Like our generation and all, we used to be streamlined, you have to do this, that, all those things. But when I'm seeing youngsters like having a lot of deviations, and deviations in the sense more scope, and all those things, it's good to see them. So institutes are playing a major role for us. We are with few IITs also doing research on all the things, surface texture from osseointegration, everything. We are associated with some medical universities also, where we are seeing the integration of the implant and growth of the bone into the implants. So it's a combined study between the engineering and the medical sector. So we are doing all those stuff. So we are waiting for, see, all those results cannot be given in one day or 2 days. Like it has to be like almost 2 years to 3 years time. So we are waiting for all those stuff to come out, like with a proper documentations.
Yes, doctor, it's an ongoing process to achieve, but I'm sure. So, how many years, doctor, in terms of it's almost 6, 7 years that you have started with your business, this under the banner of Zorian?
No, Zoriox was started in July 2019. So
Okay,
before that, I was a little freelancing. I was working with everybody. Like I was working with like you must be knowing John, you must be knowing Irai Mudi. So I was working with Armi Kannu ma'am. Like I was working with everybody. So yeah, we were actually a team initially, and we were able to do a lot of stuff. We all grew together in this field, and it was actually the happiest time for us. And yeah, now like under the banner of Zoriox, they got funded. The idea got funded for me. All those things happen. But the thing is, like when we speak about Zoriox, we are not into the commercial market yet. That I want to make it very clear with all my surgeons also. Like I always tell them, mine is not a very commercial thing. So we work with surgeons, sit with them. It's just not the surgeons ordering the implant, and I'm sending them the implant. It will be a teamwork. It's slightly a different game. It's not like what we used to do earlier. It's like we sit with the surgeon, we analyze everything what is available now to our best, and then put the implant. So we take good care of the post-op side also. So we get involved in that case, because we are a team of 5 to 6 maxillofacial surgeons. So we take good care of all those things, keep the surgeon informed or the prosthodontist informed what might happen. Before starting the case itself, we will give a list of complications. All this might can happen. Be ready for it. And like sometimes it happens, sometimes it doesn't happen. Okay, but we also find the rectification things, like how to rectify all these things. And I have been working with a few leaders in our field where they have rectified all those things, like using lasers and all. Like my seniors have given me very good inputs. So that's where Zoriox is today. We have done cases, but not in the commercial aspect. We have done it in a research aspect, both the costing also. Like we don't do it like the commercial one. We do, but the thing is, the doctor should be with us, share photos, all those things. We should be a team. That's what we want there. So that's where it's going. So like we are also working into orthotics and prosthesis, like legs and robotic hands. Like we were working on that for quite some time. That research is going on. We have researchers signed with a few robotic engineers, and it's a team, separate team where a physiotherapist, anatomist, and robotic engineers they work together, and they are also giving me feedbacks, good feedbacks. But I am not yet very happy with what's happening, so I am waiting. It has to go a long way. We were able to give leg for some one person. He's using it now, but I am not very happy the way he is using it. It's a very lightweight, and we wanted to cut the cost factor, and I was able to make that leg in just 8,000 rupees at that time. So I was able to give it to him. But yeah, definitely it's not going to be as good as the better ones. We are trying to incorporate all those things into that and make it a better one. I was able to give a robotic arm for one, the right eye hand was paralyzed, so we used a motor to lift his hand, but he also was not able to use it because the motor was heavy. So we had that problem. So that's a learning curve. So we keep improvising it. So one day we are trying to work with few institutions also, where they are working with myosensors and neurosensors. So we are working on that also, but we don't know where it goes. Right now, we are deep into the maxillofacial reconstruction because that's my core. The other things are also happening. Soon, all they will bring results. It's a big it's something like extended family. They should all bring me results. We are waiting for it.
Because it's a part of the medical ecosystem. So I
Yeah.
think it will all be connecting, and where all 3D technology can be used. Also, doctor, anything to do with orthopedics? Are you also in that area of interest?
Yeah, we have interest in that, but right now we don't have the expertise to do that. We are seeing into I've spoken to few orthopedic surgeons. Okay, but see, here my team is like me, and my team is oral maxillofacial surgeon. And who is interested in technology, we were able to bring this. But the orthopedic surgeon doesn't mostly they don't have time to do that. So it's difficult. Like if I do every part, like designing all those things, I don't feel I can do a justice to what I give to the patient. So if an orthopedic surgeon is involved with us, who has a good idea about this digital thing and all those things, then I can go ahead and see like we have gone for the printers now, metal printers, where we can do lattice structures, all those things. So now that will be a big advantage for the patients in relation to osseointegration and the more success rate.
Yeah.
So the doctors, like I'm searching for orthopedic surgeons who will be interested, not just placing these implants in, some people who are interested in making the design and then placing the implants. That's where
Yeah.
that is my team. All the surgeons who has worked with me belong to that sector. They have interest in this designing and keeping it in. That's what I see, and then we work with the surgeons.
Right, right. So we also know that these technologies are very well utilized in the acetabular cups, doctor. For
Yeah.
doctors and orthopedic surgeons who are looking at the perfect design in terms of osteointegration, lattice structure for femur implants. Also, we see in a lot of.
Yes.
So people are not looking at anymore the hydroxyapatite, the post processing, as in the coatings anymore. So this can actually achieve. So what is
Yes.
the metal machine that currently you have been able to procure, doctor?
So we are going for 350 flux, DMP 350 flux from 3D Systems. We have just bought it. It has to be shipped it. So we are waiting for it. But we have a machine in Bombay. So that's from there we are working. So, mostly in 1 month or 2 months, we will have our own setup in Chennai.
Okay.
We have taken a place. Mostly we will be operating from Gindi. So we are working on it. So soon everything will be ready.
Yeah. And the same machine can provide solutions both for orthopedics as well as dental, both,
Yes,
right?
yes, yes, yes. It's the same 23 grade titanium. So it can give the same thing. According to my knowledge.
Also, the machine will be able to cater different materials, doctor, as in cobalt, chrome, titanium, or is it?
Yeah, it can, but we are not planning to.
Yeah.
Yeah, because we don't want any 0% contamination. So we are going to stick to one material. We are not going to, because we are going for certifications. We don't want to do all the. See, you can change the bed in 350 flex and do it, the chamber and the bed. That facility is there, but still we don't want to. We are not deviating. Also, we are not going. See, the same material can be used in aerospace, but we are not going into that right now. If we are going, we are getting attached to other universities to go in those fields. We are working on that, but that will be a separate printer. But this printer which is coming in now, it's going to be completely dedicated for a medical grade 23 titanium. That's what our plan is right now.
Also, doctor, any of your complicated cases that was very difficult for you to achieve and you've been able to manage, if you can just share, which is actually helped.
Yeah, mostly all my classes are complicated. So then only it comes to us, like for 3D printing, or else they will have the other methods of reconstructing it. When everything goes for a failure or thing, then it comes to us. Yeah, there was one case. It was complicated in sense a reconstruction of mandible was done, and the thing is the fibula got resolved, and this plate, the condylar with the condylar head, the recon plate with the condylar head actually ruptured the base of the skull. It went inside the cranial cavity, and the patient had a terrible pain, and they wanted to replace everything. So they came to us for a reconstruction of mandible and closure of the base of the skull. So that was a complicated case, and we had to work on almost 10 to 15 designs to close it. To how to make this plate go inside the base of the skull. You cannot open it. It has to slide in. So there should not be any undercut, all those things. But we managed to do it, and that was a very interesting case, and we are very happy once we finished that case. And it's been almost 1 year we finished that case, and patient is doing fine. And that's the first case where we came out. There is a company called Zoriox. That's the first case which brought us out. Till that we had completed almost 40 to 50 cases, but we were keeping very quiet. Okay, this is a case which brought us out, and thanks to the surgical team who did a very great job in that case.
Thank you so much, doctor, for your inputs. I mean, I congratulate you for all the efforts being made in the space. Very best for in terms of your endeavor, because you just started in 2019 and you have been able to really position well. I think innovation and with the right techniques and expertise is always going to benefit. So, all the best for your future endeavor and the growth story. I'm sure we'll be able to capture in the subsequent interviews also as we progress,
Yes,
and also for your your bio of the machine, and I'm sure it will be helping you to achieve your results in terms of what is expected. So thank you so much for your time, and wishing you all the very best, and
thank you, sir.
great interaction with you. Thank you so much,
Yeah,
doctor.
thank you, thank you. Nice to meet you, sir. Thank you, sir. Yeah.